Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for even and odd function. When we describe a function as being even or odd, what you're doing is you're describing its symmetry. It has nothing to do with whether the degree of the function is even or odd. That's how we would determine its end behavior. But an even function is a function that has symmetry through the y-axis, and an odd function has symmetry through the origin. In this video, we're going to talk about some approaches you can take to determine whether a function is even or odd, meaning whether it has symmetry through the y-axis or origin, or maybe there's a function that doesn't have either of those symmetries. So let's take a look at what an even function is. Even functions have symmetry through the y-axis. And I have an example of one right here. You can see that this function, if you look both to the right and left of the y-axis, you see a mirrored image of itself. One way you can determine if a function's even is if you draw it on a piece of paper and fold that paper in half, where the crease would be the y-axis. And if the right side maps itself onto the left side, that means it has symmetry through the y-axis. Also, you can take a numerical approach and look at the coordinates, look at the points. If there's a point xy, that means that you should also see a point negative xy. For example, if you have the point 3, 2, you should also have the point negative 3, 2 on that same function. If you want to take an algebraic approach to determine if a function's even, what you can do is, if you have the equation, you can substitute in a negative x. And after you simplify, you should see that you end up with the same identical function. Let's take a look at an example. Right here, I have the graph of this function called b of x. It's x to the fourth plus x squared minus 1. Now, if we look at the graph of it, you can see that both to the left and right side of the y-axis, we have a mirrored image of itself. If we took this graph and folded it in half, the right side would map itself onto the left. So this does look like an even function because there's symmetry through the y-axis. If you look at, let me just write that in. If you look at the coordinates, I have this one point here. The coordinates are 0.786. And if you look at this point here, the x-coordinate is negated. So looking at the points, we can see that this is also an even function. Now, for the algebraic way to prove that it's an even function, what we do is we take our b of x and substitute in a negative x. It's just like if we substituted in a 2 or a 3 or any number you wanted. You can also put in a negative x. So the negative x goes in here and gets raised to the fourth power. Then we substitute in a negative x here. It gets squared. And then we have our negative 1. So to simplify this, if we take negative x to the fourth power, because we're raising it to an even power, that negative becomes positive. When we square negative x squared, that becomes a positive x squared. And the negative 1 is unchanged. Now, as you can see, this function, the original function, is identical to what we just got right here. So b of x is now equal to, b of negative x is now equal to our original function, b of x. That means that it is an even function. Now let's talk about odd functions. Odd functions have symmetry through the origin. They're symmetric through the origin. Again, the origin is the point 0, 0. And here is a graph of one. The trick for determining if a function's odd is actually very simple. What you can do is you can take the function and flip it upside down. When you do that, if you notice, the end behavior and the locations of the zeros are actually the same as the original. Let me do it again. If we look at this, We have end behavior, we have location of the zeros, and when you flip it, it looks the same. You can also take the numerical approach and look at points, look at coordinates. If you have a point xy, you should see the point negative x, negative y. For example, if you have the point 3, 2, you should also have on that same graph the point negative 3, negative 2, where both the x and y coordinates are negated. And if you want to do an algebraic approach, if you substitute in negative x, you don't get the original function back. You should actually get its negation back. So all the signs should be switched after you substitute in this negative x. So here's an example. I have this function a of x equal to x cubed minus 7x. Now, if you look at this graph, if you want to look at if there's symmetry through the y-axis, you look to the left and right of the y-axis, but you don't see the same thing. You don't see a mirrored image. So this doesn't appear to be an even function. But if you take this function and flip it upside down, the end behavior and locations of the zeros actually look the same. The end behavior and locations of the zeros are identical. So that tells us that this is an odd function because it has symmetry through the origin. You can also look at these coordinates. If you look at them, the signs between the two are switched. The x coordinates and y coordinates are negated. And if we want to do an algebraic approach, if we substitute in a negative x, then we plug in a negative x right here and right here as well, replacing each x from the original equation with a negative x. Now, when we cube a negative number, it stays negative. And this negative 7 times negative x becomes plus 7x. Now, unlike with even functions, we don't get the same original function back. Actually, all the signs have been switched because now this positive x cubed appears to be a negative x cubed. And this negative 7x, now positive. All the signs have been switched, which means that we could write this as a negation of our original function. Which finally tells us that if we take our function, substitute in a negative x, we get the negation of the original. And that is what we use to define an odd function. So example number 2 is an odd function. I have a third example here. It is x cubed plus 2. Now, if you look to the left and the right of the y-axis, it doesn't appear to be a mirrored image of itself. So this doesn't appear to have symmetry through the y-axis, and it can't be an even function. What about it being an odd function? Well, if we take this function in the graph and flip it upside down, the location of the y-intercept is actually at a different location, this point here. Right now it's below the x-axis. But when we flip it, now it's above the x-axis, right there. So this does not appear to be an odd function. So if it doesn't have symmetry through the y-axis, and if it doesn't have symmetry through the origin, it's neither. It's neither an even nor odd function. It has no symmetry. No symmetry through the y-axis or the origin. Now, if we just wanted to see what happens if we substituted in a negative x, because that's how we do this algebraically. To determine if it's even or odd, we want to substitute in negative x and see what the result is. And if we do that, we substitute in a negative x right here, and then we have our plus 2. When we cube a negative number, it stays negative, and this plus 2 stays plus 2. Now with an even function, when we substitute in a negative x, we get the original function back. But this function right here doesn't appear to be the original, because one has a positive x cubed and the other has a negative. And it's not the negation. With an odd function, when we substitute a negative x, if it's an odd function, we would see that all the signs would be switched, and we could factor out a negative. But that doesn't seem to be the case here. In this case, some signs changed and some didn't. If that's the case, where some signs are identical to the original and some are different, that makes this neither. It's neither even nor odd. It may have symmetry through some other means, but it doesn't have symmetry through the y-axis and it doesn't have symmetry through the origin. So please remember, even and odd functions, they have nothing to do with whether the degrees are even or odd, but it's all about symmetry. Even functions have symmetry through the y-axis, and odd functions have symmetry through the origin. Thank you for watching.